and welcome. What I'm going to be doing now is using my things from my tips to try and go through some circular motion questions. These are some questions that are 1 markers. I specifically have picked out some book questions, which are quite simple, and I've also picked out some exam questions as well to have a look at, especially in regards to looking at synopsis. So it's just a mixy blob, so don't worry about too much about the numbers on here, but I'm going to show you how some of the tips that I'm using can really help with what you're doing. So first question here is a nice multiple choice question. What is the angular speed of a point of the Earth's equator? So what I do is I highlight the word angular, and I know I'm looking for the letter omega. And that, of course, can be 2 pi f or 2 pi over t. So what I've done here is I've identified that I knew it meant angular speed, so I know it meant the letter omega, which also is hinted by the units, and that I know the formula that relates to it. So it's really important, again, that first tip I gave you, which is know your terminology. This will help. Now, they like doing this because they like doing Earth. So you know that the rotation of the Earth, the time period is 24 hours, which is 86,400 seconds. So to work out 24 hours, it's times 60 times 60. I have, from my degree, I have this number ingrained in my head, which is why I know it. So the omega is going to be 2 pi over 86,400. And even just looking at that now, you can immediately remove d because it's way too big. And if you think about it, d being 15 rads per second, whoa, that's going round or spinning round about 7.5 times every second. So yeah, so 2 pi divided by the 86,400 is going to be 7.27 times 10 to the minus 5. So the answer is A. So again, knowing what the terminology means is really useful, and actually being able to use that angular speed to actually work it out here. So these are some textbook questions, and I'm going to walk you through how I can do this. So the question on a fairground ride, so tell me that G is 9.8. A fairground ride, it descends from a height of 45 metres to a dip that has a radius of a curvature of that as shown in figure 5. So there's no figure 5 here because I've just taken it from the book. So what it means is, just to explain, it's a dippy ride like that. That is 45 metres, and at the bottom, it's a really rough diagram, would have a curvature. So the actual circle, if I made it with this, would be a radius of 78 metres. And it says calculate the speed of the train at the bottom. So speed is V, is the speed, okay, just so you know what you're looking. So this is actually more of a first year thing, where a train at the bottom of the dip, that's just an energy transfer. So this is actually just an energy transfer question. So that's going to be mgh equals a half mv squared. So the m's actually cancel. Whoops. And what you are left with is g times by h equals a half v squared. V equals the square root of 2gh. So that's going to be V equals the square root of 2 times by 9.8, because that's what they told me G was, times by 45. Yup, 45. And so that equals, so 2 times 9.8 times by 45, square root your answer, and you get an answer of 29.69 or 29.9, 29.7 meters per second. Okay, so that's just the first one. And again, identifying the terminology there. So I've got V is this. Now, let's actually have a look at this one. So question B, so let's actually use the information I've got from the top. So I know I've got this here. So I've split up the question a little bit more. So I've got my circle here, 78 meters. And I know that my V is 29.7 meters per second. I is find the centripetal acceleration of the dip, and that one is to find the extra support force, so the extra force that is needed at the bottom of this train. So again, I'm going to do my first thing. I'm actually going to find out what omega is. So I know that omega is 2 pi f, or 2 pi over t, or of course omega can be v over r. Okay, so it's actually quite useful to know that, because v equals omega r. So I'm just going to divide that here. So we're talking about this circle, so it's going to be 29.7 over 78. So that's going to be divided by 78. So omega is going to be 0.38 rads per second. Okay. And I'm trying to find the centripetal acceleration. So A equals omega squared r. So it's 0.38 squared times by 78. It's going to be 11.3 meters per second squared. So again, this is just me finding omega. Okay, I'm just going to zoom this out a little bit so you can see the whole question. So I find omega, and then I use the centripetal acceleration to find it. Now, question BII, what is the extra support force? So it wants the force that extra, okay, that of the person to actually get this going. So let's actually look at the bottom here. So at the bottom, I have this mg, and I have this tension, okay, this reaction force. And I know that this is my fourth thing, so third and fourth thing, looking at what actually was causing the force. So I know the centripetal force is up, and that's going to be tension minus the mg. So I know that the tension is going to be the centripetal force minus plus the actual weight. So I can actually work out the centripetal force, because I know this formula, or of course mv squared over r. It doesn't matter which one you're going to do. Okay. Or of course you can use F equals ma, because you know what A is as well. You could actually use that if you wanted to, because you know what the centripetal A is. Okay, so it's going to be, what is the mass of the person? A 600 Newton. Oh, that's a bit mean. So 600 Newtons equals mg. M equals 600 divided by 9.8 is going to be 61.2 kilos. Well, that was mean. So the centripetal force is going to be 61.2 times by 11.3. That's going to be 692 newtons. Okay, so the tension is going to be 692 plus 600, so that's going to be much easier just to actually do the calculator, 1291. So in this situation, the tension on the actual the struts is going to be 1,291. So this is the tension on the struts. And this is due not only to the weight, but plus the centripetal, the motion in a circle, the thing that's causing it to spin round. Oh, really hard to write this, people. Okay. The question asked for the extra support. And the extra support, okay, is basically the extra needed to move in a circle. So let's face it, if you have a look at it here, the object, if it was just balancing, if I just got the block and I stuck it, no centripetal motion, no velocity, no nothing, it is stuck at the bottom of that object, it will have a reaction force, and that's Newton's third law right there. But there is some extra force that's required, to not only keep it there, but also have it at that position there, but also move it into the circle. Okay, so that extra force, so the normal, you need 600 newtons as your reaction. The extra is the extra force is the centripetal force, which is 692 newtons. Bit of a mean question. I remember doing this the first time. So again, what I'm doing here is going through, I find omega, etc. But when I get onto the force questions, I actually draw what's going on and I write, what is the centripetal force? Cool, worked that out. And then I worked out what this tension was. And then I went, okay, so I wanted the extra support I needed. So this is the extra needed to not only have it at that position, but also have the motion in that circle. Question 3. A big wheel in a fairground has a radius of 12 meters and rotates once every 6 seconds. Okay, so radius of 12 meters and rotates every 6 seconds. Before I read the rest of the questions, I'm going to find omega. So it's going to be 2 pi f or 2 pi over t. So that's going to be 2 pi over 6, because I know the time period, so 2 pi divided by 6 is 1.05. So I haven't even looked at the question, and the first thing I did was find omega if I could. If I could find omega and I knew something about the time or the frequency, I found omega first, and that's exactly what I've done here. I'm now going to do the question, okay? So let's go back to my points. The question 3a, the speed of the rotation of the perimeter. Speed. So, speed equals v. So I'm trying to find v, okay? So I know that v equals omega r, okay? So I've already found omega because the first thing I did, so 1.05 times by 12, and that's going to be times by 12, and it's going to be 12.6 meters per second. See, by finding omega first, I've really helped myself and made it much easier. The centripetal acceleration of a person on the perimeter. So I'm trying to find the acceleration this time. So A equals omega squared r. So that's going to be 1.05 squared times by 12. Okay, so 1.05 squared times by 12 is going to be 13.23 meters per second squared there. So again, finding that omega first is really, really, really useful. So finding that centripetal acceleration of a person. The support force on a person of 72 at the highest point. So, highest point is at the top. I've got my weight going down and I have my tension going up. Now, I know at the top of it, technically the tension actually wouldn't be tension as a pull tension, it will be actually a compression. But one of the things I always do is it's habitual that I actually always draw them opposite each other. And that is because I find that with any horizontal circle, vertical circle, that if I draw this, I always draw the tension going opposite the weight, and I'm very consistent with how I do my maths. The answer is exactly the same, it's just responding. Now, I've seen sometimes some people will say that positive is always inwards to the center of the circle, and they always draw the tension inwards. I don't like doing that. This is the way I do it, and it works for me, okay? So I know that this is the circle. I always say that up is positive, okay? I know the centripetal force is going inward. So I know that the centripetal force is going that way, okay? The resultant. So resultant is going to be minus F there. And that's going to be the tension minus the weight. So the tension, the support force, is going to be the weight minus the centripetal force here. Okay, so if I go up here and they say that it's a 72 kilo person, so I know that F equals mv squared over r. So the centripetal force is mv squared over r. So 72 times by 12.6 over 12. So 72 times by 12.6 squared divided by 12 equals 952.56 newtons. mg equals 72 times by 9.8, which is 705.6. So my tension is going to be this formula here. Tension is going to be 705.6 minus 952.56. And I end up with an answer of minus 246.96, which is approximately 247. Notice the minus sign here. So this minus sign is really, really important because this gives me the direction that tension was acting in. So the minus indicates compression. So what I'm saying here is that I always have tension opposite weight in some way, shape, or form. It could be at an angle at it, but I always have it as a reaction to the weight. And what happens is when I spit out my answer comes out as a negative. And what actually means is that this reaction, instead of being a tensile force, is actually a compressive force that is coming down, and I got my tension the wrong way around. But that doesn't matter because what I try to do is when I'm doing these, I be consistent. And I always put tension weight like that. And I always draw my centripetal force. And then I label my forces. I go the centripetal force and these are the forces that are causing it. And then I rearrange it. Okay. So it's just one of those things. This is how I do it. I know some schools of thought prefer saying that the centripetal is the positive directions always to the center of the circle, and they label it like that. That's fine. If you get that, that's fine. That is not how I do it, and it's not how I get it. But I understand some people will. So it's up to you how you feel and what you feel comfortable with. Okay. The reason I do it this way is because it's more consistent for every single type of vertical circle. It may be a car going over a bump or something doing a doom reel or anything like that. It's always the same, and that's why I do it. I don't ever doubt myself. I always do it this way because it's consistent across every single vertical circle I do. Okay, so these were some book questions. Again, I'm finding like Omega all the time and things like that. So we're going on to some exam questions, and I've picked some interesting ones that are what we call synoptic. Now, this is the beauty of circular motion. It may be purely assessed in paper 1, as in like force things like this, but it sneaks into paper 2 so much, and it's so synoptic, and I'll just throw all sorts of questions on it, which is what I'm going to show you today. Okay, so this is, I'm just going to zoom into this. Is like a helicopter. Okay, so a diagram below shows a rotor blade with the arrangement used in the model. Each of the blades is 0.55 meters long. So this here is 0.55 meters long, and an end cap here has a mass of 1.5 kilograms. Okay, each and a cross-sectional blade of, so each of the blades is 0.5 meter and has a cross-sectional area of 3.55 times 10 to the minus 4 long. So the actual blade itself, if I actually looked at the blade here, the area is 3.5 times 10 to the minus 4. That's what it's asking. And you can draw little sketches, it's absolutely fine. Show that there is a force of about 7 kilonewtons acting on the end cap when it revolves around 15 revs per second. So this goes back to my first synopsis. You find omega first. So omega is 2 pi f, or 2 pi over t. So I know its frequency. So I'm going to go 2 pi divided by 15, and that's going to be 2 pi divided by 15, and my omega is 0.42. okay, rads per second. And I know that F equals m omega squared r. So that's going to be 1.5 times by 0.42 squared times by my radius here of 0.55. Ooh. I do apologise, I actually made a mistake there. My omega's wrong. I was thinking my omega felt a bit small. So it's 15 revolutions per second. So I'm going to actually be using 2 pi times by 15. Oh dear, that's why it was going a bit weird. I was thinking that seems really low. 94.24. 94.24. That sounds a bit better. So again, using F equals m omega squared r. So that's 1.5 times by 94.24 squared times by the radius, which is 0.55. So squared times by 1.5. Times by 0.55, and I get an answer of 7,328 newtons, which is approximately equal to 7 kilonewtons. Okay, so you actually get, it sounds silly, you actually get 1 mark for working out what omega was, 1 mark for substitution, and 1 mark for getting an answer which is near 7,000. You can never work backwards, you can only work forwards. So the direction in which the force acts on the end cap towards the center of the blade. So what's actually happening is the end cap here is got a velocity this way, its velocity is this way, and it is feeling a force, a centripetal force here, which is causing it to rotate this way. Okay. Show that this force leads to a stress of the blade. Now this is where it goes synoptic. So stress is force over the area. So that's going to be 7,328 divided by my area, my cross-section area. So 3.5 times 10 to the minus 4. So divided by 3.5 times 10 to the minus 4 equals 22.9, so 22.9 megapascals, which is approximately equal to that 20 megapascals that they're after. Okay, so for 2 marks on this one, you got 1 mark for, by the way, that's just 1 mark, that's just a standard. Here, 1 mark for this and 1 mark for showing the answer. Calculate the change in length. Again, I love when they do these. I love when they do synoptic questions. So calculate the change in length as the rotates. So you know that Young's modulus is stress over strain. So how I do it is I go strain equals the stress under the Young's modulus. So that's going to be 22.9 times 10 to the 6 all over 6 times 10 to the 10. Divided by 6 times 10 to the 10. My strain is 3.82 times 10 to the minus 4. And strain is change in length over the original length. So that change in length is going to be 3.82 times 10 to the minus 4 times by 0.55, because that's the length of the blade. I get 2.1 times 10 to the minus 4. Here. So you got 1 mark for that and 1 mark for that. So the answer here they have as 0.192, but of course I've been rounding or I've been using exact answers and not the answers they've been expecting. Okay. So calculate the strain energy stored in one of its due to its extension. So strain energy, so energy equals a half Fx. So half times by the force of 7,328 newtons times by the extension of 2.1 times 10 to the minus 4. So times by 7,328 times by 0.5. and I get an answer of 0.77 joules. Again, there's error carried forward, which means that it's not an error carried forward. This is my rounding being carried forward. Again, nice 2 marker using synoptic, going back with circular motion. So this is, by the way, a fantastic question because it is highly synoptic. There's circular motion, and this could be asked in a paper 1. This guarantee could, because this is the kind of thing that they would do. They'd have a nice circular motion question here, then a Young's modulus question. And what we're going to go into now is we're actually going into density, and we're going to go into momentum, which is even more interesting. So the model helicopter can be made to hover above a point on the ground by directing the air, the rotor vertically downwards with a speed of v. Show that the momentum of air each second is a rho v squared, where a is the area swept back by the blades. So if I actually drew what's happening here, you have a nice circle like that. This is where the blades are. Okay, there's the blades. And it's taking out some air here. Okay. So they're after the momentum of this air. So momentum, which is P, is mass times the velocity of the air. The mass, the minute you see this, the minute you see density like that, you please write the density formula out. So mass is going to be rho times by V. Okay, and be aware that I'm using 2 different V's here. Okay, I've got velocity there. Now, V is the volume. The volume of this object here is going to be the cross-sectional area A times by the height. Okay, and this is one of the things I love doing. They like doing this. I show that the momentum each second is rho v squared. So they're after what is the area, the volume, each second. So the area isn't changing every second. The height of the air will. The height is going to be the velocity, okay, because that is going to be the meters per second displaced. So the height per second is the height of that air displaced. So the volume per second, equals area times the volume, velocity there. So I know if putting it all together, I end up with mass equals rho times by the area times by the velocity. And P equals the mass, so rho times the area times the velocity times by the velocity, which then equals rho A V squared. Okay, mean question, but I draw diagrams to help me. Okay, so the volume of each second is area times the height at that second, and the height per second is how basically the velocity, okay, because that's the distance per second. So there's only 2 marks available for this, but 1 for the actual maths and 1 for sorting it out there. The model, this has a weight of 900 newtons. So the weight is 900 newtons. Okay, calculate the speed of the air downwards when it has no vertical motion. Okay, so here, if the weight downwards, if I should draw my diagram, if I had a little helicopter, my weight downwards is 900 newtons. This means my lift must also be 900 newtons. And this comes back to the idea, okay, that you realise that force times time equals the change in momentum, okay, impulse. And because we are looking at per second, T equals 1, okay. So F equals mv, or momentum. So F equals rho a v squared. So by the way, massive hint with the question before. So 900 equals 1.3 times by your area. So this is area that's swept up, by the way, of the thing. So that's pi r squared. So 0.55 squared times by pi equals 0.55 squared times by pi. 0.95. So 0.95 times by v squared. V equals, so 900 divided by that, divided by 1.3. Oops, answer divided by 1.3. And then square root your answer, and you get 20. I got 26.99 or 27 meters per second. Okay, so if they ever give you a question where it says before, prove that something is something, like this equation, and the next question down asks you something to do with numbers, it's normally to do with the equation above. So this question here is worth, in its own right, 3 marks, 1 for the answer, 1 for the solving, and 1 for actually them realising that you noticed that it was 900 newtons as the force. So this is quite an interesting one because this has, not only does it have circular motion, it also has Young's modulus of materials, it also has momentum, it also has density. So this is quite a nice little question that has a little bit of everything in it, okay? But again, what I'm doing most of the time, I draw diagrams, I try and work out what's going on. So let's do another synoptic question. So this question here, a Bohr model of a hydrogen atom assumes that the electron E is in a circular orbit around a proton P, and it's shown in figure 1. The ground state of the orbit has a radius of 5.3 times 10 to the minus 11, and a separation is attracted by the proton of a force of 8.1 times 10 to the minus 8 newtons. So I know that this electron is attracted, so the force going in, so F equals 8.1 times 10 to the minus 8 newtons. First question. This is a first year thing. State what is meant by the ground state. And so it's the lowest energy state of an electron. An electron. So it's basically, it's the state, the ground state is the lowest energy state of the electron. It's the electron when it's not being given any extra kinetic energy. It is literally in orbit around the electron. There's nothing extra being given to it there. And that itself is just worth 1 mark. Show that the speed, now that again, this is where my words speed, so I'm looking for the letter V of the electron of the orbit is 2.2 times 10 to the 6. The mass of the electron is 9.1 times 10 to the minus 31. So I know that the force, I'm looking for V, so I immediately write that down. I don't have enough information to find omega, but I have highlighted that I'm after V. I know that F, what I've done here is I've identified that the centripetal force is this. This is the centripetal force. This is the attracted. I've drawn a diagram. I went, okay, that's the force into the center of the circle. So I'm trying to label as much as I can here. So I know that 8.1 times 10 to the minus 8 equals 9.1 times 10 to the minus 31 times by v squared all over the radius of 5.3 times 10 to the minus 11. Okay, so just bung it into the formula. So v squared is going to be, so 8.1 times 10 to the minus 8 times by 5.3 times 10 to the minus 11 divided by 9.1 times 10 to the minus 31. And I get 4.7 times 10 to the 12, and if I square root that, I should have a nicer number of 2.17 times 10 to the 6 meters per second, which is approximately equal to 2.2 times 10 to the 6 meters per second. Okay, I always write what the decimal point is, and then I say it's approximately equal to it. So 1 mark for actually using the formula, 1 mark for doing it, and 1 mark for actually getting the answer there. So again, this is a circular motion question, and what I've done is I've made sure I've identified that the speed that they meant was in meters per second, so I label that. I also went, I actually drew in the diagram, went, okay, the force of attraction. So that's the force pulling them together. So I drew that on the diagram. And that's a nice circular motion question there. Calculate the de Broglie wavelength of the electron. So lambda, is h over mv. So the de Broglie wavelength lambda equals h over mv. So it's going to be 6.63 times 10 to the minus 34 over 9.11 times 10 to the minus 31 times by 2.2 times 10 to the 6. So you can actually do this bit without the bit above. So 6.63 times 10 to the minus 34 divided by 9.11 times 10 to the minus 31 divided by 2.2 times 10 to the 6. And I get an answer of 3.3 times 10 to the 10 minus 3.3 times 10 to the minus 10 minus 10 meters. So that's my de Broglie wavelength there. How many wavelengths fit into the circumference of the electron orbit? Show your reasoning. Okay, so I know that a wavelength is going to be 3.3 times 10 to the minus 10 meters. The circumference equals 2 pi r. So that's 2 times pi times whatever the radius was. So the radius is 5.3 times 10 to the 11. So that's 3.3 times 10 to the minus 10. So how many waves of this will fit into there? So 3.3 times 10 to the minus 10 divided by 3.3 times 10 to the minus 10 equals 3.3 times 10 to the minus 10 equals 1 wave. So you're going to get, you could have actually just seen that anyway, you could have got 1 wave there. So I'm just showing my maths there. So you got, this is quite nice there after 1 mark for that and then 1 mark for saying 1 wave, and that's it. It's one of those deceptively simple questions that they're asking you on here. Okay, so the quantum theory suggests that the electron and the hydrogen atom can only exist in certain well-defined energy states. Some of them are drawn on figure 2. An electron E of energy of 2.5 times 10 to the minus 8 collides with a hydrogen atom, that is at its ground state, and excites the electron to n equals 3. Calculate the energy needed to excite an electron in the hydrogen atom from the ground state to n equals 3. Okay. So what's actually happening here is that an electron E of energy that collides with this hydrogen atom. So we're up here, and what's happening here is the object is moving from here all the way up to here. Okay, so to do that, I'm going from 21.8 to minus 2.4. So how much energy do I have to add in? Is this electron volts or it's in energy here? So I'm going to be adding plus 19.4 times 10 to the minus 19 joules. So I'm adding that much energy to get to that level there. Okay. So here I've got minus 21.8 going all the way to minus 2.4, which equals 19.4 times 10 to the minus 9 joules of energy need to be added to go from that position to that position. Calculate the kinetic energy of the electron after the collision. So what's actually happening is the electron comes in, and then it will, with how much energy? 2.5 times 10 to the minus 18. And then what will happen is it's going to lose, so it will give the hydrogen energy. I've just calculated that as 19.4 times 10 to the minus 19 joules. Okay, so the energy in, I've already lost some energy here, so it's just the difference between these two. So 2.5 minus 1.94. So 2.5 minus 1.94 is 0.56. So it's 0.56 times 10 to the minus 19. Oops, 18 joules there. Okay, as you may notice, I cheated here. I kind of removed the figures, and that's what I used there. So it's just a 1 mark question, and it's literally just for taking 2 numbers away, which is quite nice. The wavelength of the lowest energy photon could be emitted as an excited electron returns to the ground state. So what it's asking here, the wavelength of the wavelength of the lowest energy photon that could be emitted as the excited electron returns to its ground state. Okay, so what's actually happening here is the wavelength of the lowest energy photon that could be emitted. So if we actually look at this here, the electron goes up to n equals 3. So it's asking for what is the lowest amount of energy that could be sort of any difference here. So what is the lowest, read the question again, the wavelength of the lowest energy photon that could be emitted. So by doing this here, it's going up to n equals 3. When it comes back down, it could emit this one, it could emit this one, or it could emit this one. It could emit any one of those photons. So it could emit this one, it could emit this one, or it could emit this one. And it wants the lowest energy one. Okay, so it's the one with the smallest amount of energy, which is going from n equals 3 to n equals 2. That's the smallest amount it could have emitted. So going from n equals, so these are not my notes, there we go, that's about it, n equals 3 to n equals 2, I'm going from minus 2.4 to minus 5.4. So the change in energy is going to be 3 times 10 to the minus 19 joules. Okay, so the wavelength, I know that E equals HF. So I can work out, or of course you've got HC over lambda. So lambda is going to be HC over the energy. So you can have 6.63 times 10 to the minus 34 times by 3 times 10 to the 8 all over the actual energy it has. So 3 times 10 to the minus 19. So that's going to be, bring it into my calculator, so 6.63 times 10 to the minus 34 times by 3 times 10 to the 8 divided by 3 times 10 to the minus 19, and I get an answer of 6.63 times 10 to the minus 7 meters, which is approximately about 663 nanometers. So we're well within sort of the red range right there. Okay, so this is a nice 3-mark question where they wanted, the first mark is for identifying the gap of the lowest energy. The second mark is for doing the formula, and the last mark is for the answer here. Now you can actually get a mark here even if you pick the wrong answer. So if you pick the wrong energy gap, you could have actually picked up a mark here for doing this. They're actually being quite generous. It says energy difference. So if they notice that you know any gap, but you will just not get 3 out of, you wouldn't get 3, you'd only get 2, 1, maybe 2 marks out of that. But as you can see here, this is a perfectly valid for paper 1 because it's got a little bit of circular motion, and then it goes completely synoptic really quickly. So there you have it, guys. That is me using my tips and hints and how to actually answer some questions regarding circular motion, both synoptic and not. And hopefully that will help you guys in the